Okay, so of course, module 16 is network security fundamentals, and then module 17 is basically a scenario on how to build a small network. So network security fundamentals, and so we're going to look at security threats and vulnerabilities. We'll look at network attacks, how we mitigate those attacks, and then we'll look at how we can secure our devices to make them a little bit more secure. So, threats and vulnerabilities. So, types of threats. So, attacks on a network can be devastating, can result in a loss of time and money due to damage or theft or important information or assets. Intruders can gain access to a network through software vulnerabilities, hardware attacks, or through guessing someone's username and password. Intruders who gain access by modifying software or exploiting software vulnerabilities are called threat actors. So after the threat actor gains access to the network, 4 types of threats may arise. So information theft, data loss and manipulation, identity theft, or disruption of service. So types of vulnerabilities. So a vulnerability is the degree of weakness in a network or a device. Some degree of vulnerability is inherent in routers, switches, desktop servers, and even security devices. Nothing's perfect. They're all made and designed by humans. Typically, the network devices under attack are the endpoints, such as servers or desktop computers. There are 3 primary vulnerabilities or weaknesses. And so there are technological vulnerabilities, and so they might include TCP/IP protocol weaknesses, operating system weaknesses, or network equipment weaknesses. There's also configuration vulnerabilities, and so that's when you might have unsecured user accounts, system accounts with easily guessed passwords, misconfigured internet services, unsecure default settings, and misconfigured network equipment. And so security policy vulnerabilities might include a lack of a written security policy, politics within the organisation, lack of authentication continuity, logical access controls not being applied, software and hardware installation and changes not following policy, and a non-existent disaster recovery plan. All 3 of these sources of vulnerabilities can leave a network or device open to various attacks, including malicious code attacks and network attacks. Now, physical security is something that should not be forgotten. And so if network resources can be physically compromised, the threat actor can deny the use of network resources. And so the 4 classes of physical threats are as follows. So hardware threats, so this includes physical damage to servers, routers, switches, cabling, plant and workstations. Environmental threats, so extremes in temperature or humidity. Electrical threats, so of course you can have voltage spikes, loss of power, brownouts, which means a low supply of voltage, or noise from a dirty generator, basically, as in dirty as in a poor wave, an untidy waveform. Maintenance threats, so this includes poor handling of key electrical components. Electrostatic discharge could be one of those causes. Lack of critical spare parts, poor cabling and poor labelling. A good plan for physical security must be created and implemented to address these issues. All right, network attacks. So, of course, malware can be part of this. And so, of course, malware is short for malicious software. It is code or software specifically designed to damage, disrupt, steal, or inflict bad or illegitimate action on data, hosts, or networks. The following are types of malware. So viruses. Computer virus is a type of malware that propagates by inserting a copy of itself into and becoming part of another program, hence the name virus. It spreads from one computer to another, leaving infections as it travels. Computer worms are similar to viruses in that they replicate functional copies of themselves and can cause the same type of damage, in contrast to viruses which require the spreading of an infected host file. Worms are standalone software and do not require a host program or human help to propagate, and they can actually move themselves across networks as well. And then there's Trojan horses. It's a harmful piece of software that looks legitimate. Unlike viruses and worms, Trojan horses do not reproduce by infecting other files. They self-replicate. And the Trojan horses must spread through user interactions, such as opening an email attachment or downloading and running a file from the internet. And so if you've ever heard of scareware, where they say, oh, if you ever gone to a website and it said, hey, we've found X number of vulnerabilities in your computer, download this software and we'll fix it all for you. Well, you're probably downloading a Trojan horse, and you're actually causing the problem they're saying is already a problem. All right, so when it comes to network attacks, they will normally start with reconnaissance attacks. And so in addition to malicious code attacks, it's also possible for networks to fall prey to various network attacks. And so network attacks can be classified into three major categories. So reconnaissance attacks are basically you are discovering what devices are there, what type of operating systems they run, what services they're running, what versions of those services they're running, and then you can actually figure out what vulnerabilities they might have. And so then after the reconnaissance, then it's typically one or the other. So it's either an access attack, so you get unauthorized manipulation of data, systems access or user privileges, or denial of service, which basically tears the system down in some way or other, where valid users can't access their networks or services they need. For reconnaissance attacks, external threat actors can use internet tools such as NSLookup and Whois utilities. That will give some general information about, who has this domain name, who runs it, and what addressing they have, and all kinds of stuff like that. So they can easily determine the IP address space assigned to that given organisation. After the IP address space is determined, a threat actor can then ping the publicly available IP addresses to identify the addresses that are active, and then from there they can actually do all kinds of port scans and other such nasty things if they're trying to attack you. So with an access attack, they normally exploit known vulnerabilities in authentication services, FTP services and web services to gain entry to web accounts, confidential databases and other sensitive information. So there's four major types of access attacks. So there's password attacks. So typically that means a brute force attack where it just runs through a database of usernames and passwords and tries to hack their way in. So they might try to, of course, use a Trojan horse to get some software on the inside of your network, or they might use packet sniffing to try and find out what's going on. Now, trust exploitation, where a threat actor uses unauthorized privileges to gain access to a system, possibly compromising the target. With port redirection, a threat actor uses a compromised system as a base for attacks against other targets. For example, a threat actor might be using port 22 to connect to a compromised host A. Host A is trusted by host B, and therefore the threat actor can then use Telnet to access it. And another type of attack can be man in the middle, where the threat actor is positioned between the two legitimate entities in order to read or modify the data that passes between them. All right, so denial of service attacks is where are probably the most publicised form of attack and among the most difficult to eliminate. However, because of their ease of implementation and potentially significant damage, denial of service attacks deserve special attention from security administrators. So there's many forms of DOS attack. Ultimately, they prevent authorised people from using a service by consuming system resources. To help prevent DOS attacks, it is important to stay up to date with the latest security updates for your operating systems, applications, and again, operating systems on your devices. DOS attacks are a major risk because they interrupt communication and cause significant loss of time and money. These attacks are relatively simple to conduct, even by an unskilled threat actor. And so distributed denial of service, or DDoS, is similar to a DOS attack in that the end result is people can't access those services. But DDoS originates from multiple coordinated sources. So, for example, a threat actor builds a network of infected hosts known as zombies. A network of zombies is called a botnet. The threat actor uses a command and control CNC program to instruct the bot of zombies to carry out a DDoS on a particular address or domain. And so how do we mitigate these attacks. And so there's a defense-in-depth approach is a way of protecting yourself from a lot of things. So to mitigate network attacks, you must first secure devices including routers, switches, servers and hosts. Most organisations employ a defense-in-depth approach, also known as layered approach to security. This requires a combination of networking devices and services working in tandem. So several security devices and services are implemented to protect an organisation's users and assets against TCP/IP threats. So VPNs, of course, virtual private networks, are a way that you can communicate in and out of that network encrypted and therefore have your data protected. That would make man-in-the-middle attacks a little difficult. ASA Firewall, well, that's a Cisco brand name, is ASA, Advanced Security Appliance, I think stands for. And so that is a firewall device, of course, and they're designed to be a barrier between your inside network and the rest of the world. IPS is intrusion prevention systems, and so they will actually monitor your traffic, and they will typically using signatures, a bit like a virus scanner. They will actually identify attacks that may be happening, and they'll actually block that traffic, hence the prevention. ESA WSA is mostly about access to the networks. And a AAA server, AAA stands for Authentication, Authorization and Accounting. And so basically, of course, authentication is, it's a good scalable solution that makes authentication work well. Or authorization, of course, is a way that you can control who can do what. And accounting rarely has anything to do with money. It's actually basically logging of everything that's happened, so you can actually trace back through it. All right, so another preventative measure, preventative of disaster measure, is backups. So backing up device configurations and data is one of the most effective ways of protecting against data loss. Backup should be performed on a regular basis as identified in the security policy. Data backups are usually stored off-site to protect the backup media if anything happens to the main facility, building burns down or something nasty like that. And so backup considerations and their descriptions. And so how often frequency, of course, is how often should you do your backups. And so you should do it on a regular basis as identified in the security policy. So assuming the security policy is well designed and sensible, so it would actually have figured out a frequency for you to do it. So full backups, of course, is a backup of absolutely everything. They're very useful, but they are time consuming. So most businesses will not do a full backup every night. They may well do it monthly or weekly. And then you do partial backups for all the files that have changed since that last full backup to protect yourself on a daily or more often basis. So storage. So of course you need to store the backups, and so you need to validate those backups to ensure the integrity of the data and validate the file restoration procedures. So there's not much good having backups if you can't restore it reliably, so you should practice that every now and then and make sure it does work. So security, of course, backups have all your data in it, and so you need to have that secured. Otherwise people can steal your data from your backup instead of from your live machines, and so you've got to be careful about that. And so whether you encrypt it or how you store it securely is something to consider. And so validation backup should be protected using strong passwords. The password is required to restore the backup. Now, of course, another solution is to ensure that your devices have the latest version of the operating system and all the patches. So upgrade, update, and patch. As new malware is released, enterprises need to keep current with the latest versions of antivirus software. The most effective way to mitigate a worm attack is to download the security updates from the operating system vendor and patch all vulnerable systems. one solution to the management of critical security patches is to make sure all end systems automatically download updates. And so you can have them, for instance, for Windows, you can have them all talking to Microsoft and doing it automatically. Inside an enterprise, you might actually have your own server that does that. So you can maybe save a bit of bandwidth and the like, and have a little bit of extra control of what happens. And so all operating systems need updates. None of them are exempt from this, because all operating systems are written by humans. They all have errors in them. And yes, Mac OS is vulnerable. Apple might lie to you and tell you it's not, but it is, just like any of them. About the only major security advantage that Mac OS has over Windows is that it's a little more obscure. There's nowhere near as many of them. And so it's not as big a target. That's the only advantage they've got, really. And so again, Linux also has vulnerabilities, and I suppose that's certainly security by obscurity. I quite like Linux, but yeah, I'm going to say that it'd be lucky to be 1% of the computers on the planet. Why would you design an attack for that when you could attack 90% of them using on Windows? So that's why Windows has a problem, is that they're the big boy in town. All right, so as I said, AAA is authentication, authorization, and accounting. And so network security services provide the primary framework to set up access control on network devices. It's a way to control who is permitted, authentication, what actions they can perform, which is authorization, and making a record of what was done while they were there. And so that's the accounting. The concept of AAA is similar to the use of a credit card. The credit card identifies who can use it, how much that user can spend, and keeps account of what items the user spent money on. And so that's their analogy. Also, we've all set up routers and switches with usernames and passwords and all things, and those passwords and things. It can become a bit of a faff after a while. And imagine working for a big business that has quite possibly hundreds or thousands of switches and routers all over the place. You can actually use a AAA server to do all your authentication, and so you can actually authenticate maybe your Windows account, Windows Server account, as being the account that they log into to your router or switch with. If you set it up right, that can actually happen, and so then you know exactly who's done it. Okay, so firewalls, of course. So basically, there's two types of firewalls. There are host firewalls, and then there are firewall devices which are on the border between your networks. So network firewalls are, of course, reside between two or more networks and control the traffic between them and help prevent unauthorized access. So a firewall could allow outside users controlled access to specific services. For example, servers accessible to outside users are usually located on a special network referred to as a DMZ, or demilitarized zone. And the DMZ enables a network administrator to apply specific policies for hosts connected to that network. So you could say, well, for the DNS server, there are people allowed to connect using port 53 only. That makes sense. And if it's a web server, port 80 or port 443 only, and things like that. So you can actually create rules that allow certain traffics, block all other traffic. Okay, so there are sort of different types of firewalls out there. Firewall products come packaged in various forms. These products use different techniques for determining what will be permitted or denied access to a network. They include the following. And so packet filtering is very basic access control listing, and it's just based on IP or MAC addresses, typically IP addresses. Application filtering prevents or allows access by specific application types based on port numbers. And so, again, instead of looking at the layer 3 IP address, you can look at a combination of their IP address and what port numbers they're trying to connect to. URL filtering prevents or allows access to websites based on specific URLs or keywords, and so you can have maybe a white list where all of that's the only places people are allowed to visit are on that white list, or you can have a black list which says you can go anywhere except for those websites that are listed on this black list. And so then there's stateful packet inspection, and often you may well have a combination of all of these. And so stateful packet inspection on a firewall basically means incoming packets must be legitimate responses to requests from internal hosts. Unsolicited packets are blocked unless permitted specifically. Stateful packet inspection is also includes the capability to recognise and filter out specific types of attacks, such as denial of service. So basically, with stateful inspection, unless you've got rules permitting certain traffic coming from the outside world, it will really only allow connections that were initiated by hosts from the inside of the network. So, of course, we spoke about the transport layer a couple of lessons ago, and so, of course, the three-way handshake is what that firewall actually takes notice of, and so it takes notice of the SYN, SYNAC, and ACK packets, so it knows when an internal host is actually initiating a connection, and so it will actually keep track of that, and so it keeps track of its state. That's why they call it a stateful packet inspection, and so it keeps track of that conversation as it goes, and when it sees the FIN packets to close the connection, it will then throw away the data that it has kept about that because it knows the conversation's finished now. So it's a very smart way of doing things. So, of course, that firewall we'll be talking about mostly are those border ones, that one on the edge of your network that, you know, separates your network from the rest of the world. Of course, the rest of the world you don't trust. Now, an endpoint or host is an individual computer system or device that acts as a network client. Common endpoints are laptops, desktops, servers, smartphones, and tablets. And so you need to secure those devices as well. And so it's one of the more challenging jobs for a network administrator because it involves human nature. A company must have well-documented policies in place. Employees must be aware of these rules. So employees need to be trained on proper use of the network. Policies often include the use of antivirus software, host intrusion prevention. More comprehensive endpoint security solutions rely on network access control. All right, so device security. Now, we're talking about Cisco devices here. Now, Cisco AutoSecure is basically, it's a script that you can run. So you can actually sit down at a Cisco device and type in AutoSecure. It will actually just ask you a whole pile of questions. And so the security settings are set to the default values when a new operating system is installed on a device. In most cases, the level of security is inadequate. For Cisco routers, the Cisco AutoSecure feature can be used to assist securing that system. In addition, there are some simple steps that should be taken that apply to most operating systems. So don't use default usernames and passwords. They should be changed immediately. So I'm going to say on Cisco devices, you don't have default usernames and passwords, well, most of them, because it doesn't have any. You need to create them. So that's, of course, something you need to remember as well. But on other devices, so, you know, when you've bought a router or something from a store, it will often have a default one. Then the user manual might say use the username admin and the password or whatever it might be. And so that's all very nice for your initial access. First thing you should do is change that bloody thing. Because there are websites out there that actually tell you the default username and password for all those different models of all those different devices. And so if you've left it to default, you've actually left yourself open. So access to system resources should be restricted to only individuals that are authorised to use those resources. Any unnecessary services and applications should be turned off and uninstalled when possible. Often devices shipped from the manufacturer have been sitting in a warehouse for a period of time and do not have the latest version of the operating system or patches. It is important to update any software and install any security patches prior to implementation. Okay, so passwords, of course. And so for strong security, you should have strong passwords. So here are some standard guidelines to use. Use a password length of at least 8 characters, maybe 10. Don't make them too long, because that's when you start making people write it down on a piece of paper, and that negates their security. So you've got to have a balanced approach. You should try to make passwords complex, mixture of upper and lower cases, numbers, symbols, and spaces, and the like. And so avoid passwords based on repetition. Common dictionary words, because they're going to be in that brute force dictionary that they use to attack it. Letter or number sequences, usernames, relative or pet names, biological information such as birth dates, ID numbers, ancestors' names, pets' names, certainly. Deliberately misspell a password. For example, you might do Smith as Smythe, might replace an S with a 5 because it looks a bit like it, and all kinds of things like that. Change passwords often. If a password is unknowingly compromised, the window of opportunity for the threat actor to use the password is limited. Do not write passwords down and leave them in obvious places such as on a desk or on the monitor. On Cisco routers, leading spaces are ignored for passwords, but spaces after the first character are not. Therefore, one method to create a strong password is use the space bar, create a phrase made of many words. This is called a passphrase. And so it's often easier to remember than a single password. It is also longer and harder to guess. So I've got to admit, at one stage, I haven't used it for a while. I actually used, he's not the Messiah, he's a very naughty boy. Anyone know that?
Yep.
Life of Brian. So, now, settings you can do on your Cisco device. And so we have covered at least some of these before, so service password encryption. So, of course, that saves you from someone shoulder surfing when you look at the config. Start a minimum acceptable password length, and so there's actually the command here. Security password minimum length 8 characters. And so suddenly Cisco and class aren't going to work on this device. You can actually have a login block. So basically, brute force attacks, and so there's this line here, login block for 120. So if there's been a violation, we're going to stop access for 2 minutes. When you've had 3 failed attempts to log in within 60 seconds. And so that will, so you're basically going to get 3 login attempts every 2 minutes. That will slow down a brute force attack very much. Also should ring some alarm bells for you as well. Also, if you've got an inactive connection, you should probably set an exec timeout. And so here it's 5 minutes, 30 seconds. And so if you're telnetted into that device and you don't do anything, you don't type anything for 5.5 minutes, it's going to chop you off. I think they've done 5.5 because I think the default time is actually 5 minutes. But anyway, it does have an exec timeout. But of course, you might want to change it. Okay, now SSH. We've spoken a lot about, well, a few times at least, about SSH, but we haven't actually told you how to configure it yet. So here's the day. And so to configure a unique host name, you need to do that as well. So first thing you do is you need to have a host name for that computer. You can't list all that device, so you just can't leave it as router or switch. So you need to give it a name of some sort. You also need to give it a domain name. And so, of course, in this, you might use tafersa.edu.au or flinders.edu.au or, cisco.com or whatever it might be. And so, of course, that means combining the host name with the domain name, it gives you a fully qualified domain name. And that's needed for an SSH server. Then you actually, after you've done that, then you can actually generate an encrypted SSH key. Now, SSH uses asymmetrical encryption. Have we spoken about encryption yet? Probably not in any great depth. There's 2 types of encryption. One is called is symmetrical, and that's where both the sender and the receiver need to know the same key. It's very efficient, but the problem is, how do they both end up knowing the same key? And so there is another method called public key, or basically public key, PKI, public key infrastructure. And so basically what happens there is you have 2 keys that have a mathematical relationship to one another. And so basically, if you encrypt data with one of those keys, you need to have the other key to decrypt it. And so basically we call one of them a public key, the other one of them a private key. Now in this case, basically, when you generate the SSH key, it will create two keys. One is the public key, and that is actually given to each device as they connect to SSH. And the other key, of course, is just kept on that device and not shared with anyone. And so basically what happens is when a host wants to transmit some data to your device, it will actually encrypt it with that public key, and the only device on the planet can decrypt it is that device. And so that's rather good. Now, that's a very, very quick and dirty explanation of asymmetrical encryption, but it's very handy, but it's a little bit inefficient when it comes to encryption. So actually, normally the first thing that happens is we'll actually share a symmetrical encryption key with it, and then that's how we'll do our encryption from there on in. And so you also need to have a username and password database on the device. So you actually have to create that on a device. You then have to configure the VTY lines to actually use the local database. And then, of course, you need to enable SSH on the VTYs. And so I think there's an example coming. Okay, would have thought it was the next slide, but anyway. So you need to disable unused services. So Cisco routers and switches start with a list of active services that may or may not be required in your network. You need to disable any unused services to preserve system resources, and also it means you're less vulnerable to attack, basically. The type of services that are on by default will vary depending on the iOS version. So iOS XE typically will only have HTTPS and DHCP ports open. You can verify this with show IP ports all. iOS versions prior to iOS XE will use the show control plane host open ports command. Okay, that has not demonstrated SSH. I thought it would have in the slides. But anyway, after the threat actor gains access to the network, 4 types of threats may arise: information theft, data loss and manipulation, identity theft, and disruption of service. So the 3 major vulnerabilities are technological configuration and security policy weaknesses. The 4 classes of physical threats are hardware, environmental, electrical, and maintenance. Malware, of course, stands for malicious software. It's code or software specifically designed to damage, disrupt, steal, or inflict bad or illegitimate action on data hosts or networks. Viruses, worms, and Trojan horses are the major types of malware. Network attacks can be classified into 3 categories: reconnaissance, access, or denial of service. To mitigate network attacks, you must first secure devices including routers, switches, servers, and hosts. Most organisations employ a defence-in-depth approach to security. This requires a combination of networking devices and security services working together. Several security devices and services are implemented to protect users and assets against TCP/IP threats, so the VPN, ASA, or firewalls, IPS, ESA, WSA, so that's actually just email and web security. And AAA is, of course, authentication, authorization, and accounting. All right, so infrastructure devices should have backups of configuration files, and there are iOS images on an FTP server or similar file server. If the computer or router hardware fails, the data or configuration can be restored using that backup copy. The most effective way to mitigate a worm attack is to download security updates from the operating system vendor and patch all vulnerable systems. So, yeah, worms normally use some kind of vulnerability in the operating system. So if anyone remembers, what was it, Code Red? It was an attack that was, nearly 20 years ago, but it went ballistic around the world within hours. It went from about 50 infections to several 100,000 within about 3 or 4 hours, because back in the early 2000s, hardly anyone patched their devices. And so the vulnerability that Code Red was written to exploit had actually been patched about 4 months before the attack happened. And so if everyone had patched their devices, Code Red wouldn't have gotten far at all. but because hardly anyone was in the habit of doing that, it went very, very hard indeed, and caused a lot of problems. So to manage critical security patches, to make sure all end systems automatically download updates. So of course AAA is how you can authenticate, authorize and account for what's happening on the networks. Network firewalls reside between two or more networks. They control the traffic between them and help prevent unauthorized access. Securing endpoint devices is critical to network security. A company must have well-documented policies in place, which may include the use of antivirus software and host intrusion prevention. More comprehensive endpoint security solutions rely on network access control. I think this is the last slide. For Cisco routers, the Cisco AutoSecure feature can be used to assist securing the system. For most operating systems, default username and password should be changed immediately. Access to the system resources should be restricted to only the individuals that are authorized to use those resources, and any unnecessary services and applications should be turned off and uninstalled when possible. To protect network devices, it is important to use strong passwords. Passphrase is often easier to remember than a simple password. It is also longer and harder to guess. For routers and switches, encryptable plain text passwords, setting a minimum acceptable password length. We can deter brute force password guessing attacks and disable an inactive privileged exec mode access after a specified amount of time. Configure appropriate devices to support SSH and disable unused services. So there's the logo. So as I said, the next chapter, which is 17, is basically a scenario on how to implement a network. See you then.